How to measure signal-to-noise ratio in chromatography. Signal-to-noise ratio is one of the most commonly referenced metrics in chromatography, particularly in gas chromatography (GC) and liquid chromatography (HPLC). Despite this, it is often misunderstood, especially when chromatographic peaks are quantified by area while baseline noise is reported in detector voltage units. In this video, I'll explain how signal-to-noise ratio should be measured in chromatography, and then show how Chromperfect implements this calculation transparently using formatted reports. Signal-to-noise in GC and HPLC, the core principle. In both GC and HPLC, signal-to-noise ratio is a comparison between the amplitude of a chromatographic peak and the baseline variation of the detector signal. Baseline noise is a property of the chromatogram trace itself. It represents random variation in detector output when no analyte is present. Because of this, signal-to-noise must be calculated from detector voltage, not from integrated peak area. Peak area and baseline noise do not share compatible units and cannot be compared directly. For this reason, signal-to-noise in chromatography is defined using peak height and baseline noise, both measured in the same units. Measuring baseline noise in chromatography. In chromatography data systems, baseline noise is measured directly from the chromatogram trace over a defined time interval. That interval should be free of peaks, so the measurement reflects true baseline variation rather than analyte response. Chromperfect measures baseline noise using chromatogram functions that operate directly on the chromatogram trace, rather than on integrated peak results. Defining the noise interval using user fields. In Chromperfect formatted reports, user fields are used to define the noise measurement interval without hard-coding values into the report. One user field defines the start time of the noise interval, and another defines the end time. The duration required by the chromatogram function is calculated as the difference between these two values. This approach allows the same report to be reused across GC and HPLC methods, while ensuring that noise is always measured in an appropriate, peak-free region of the chromatogram. Calculating RMS baseline noise with the MBN function. RMS baseline noise is calculated using the MBN chromatogram function within a user formula. The function operates directly on the chromatogram trace and returns a single RMS noise value for the defined interval. This value represents baseline variation only and is not influenced by peak integration, peak width, or reporting format. The report header is used to display both the selected noise interval and the calculated RMS noise value. Including this information directly in the report makes the signal-to-noise calculation transparent and auditable. Anyone reviewing the report can immediately see where noise was measured and what value was used. Calculating signal-to-noise ratio for each peak. With RMS noise defined, signal-to-noise ratio is calculated for each peak using peak height. Peak height is measured in detector voltage units and represents the amplitude of the chromatographic signal above baseline. Because peak height and RMS noise share the same units, the resulting signal-to-noise ratio is physically meaningful and directly reflects detector performance. The same noise measurement is applied consistently to all peaks in the report. Example report, GC and HPLC data. This example report shows a real-world application of the signal-to-noise calculation. It includes a chromatogram view showing the peak-free region used for noise measurement, a full chromatogram view of the entire analytical run, the selected noise interval, the calculated RMS noise value, peak heights, and the resulting signal-to-noise ratios. Once the report is configured, these values are calculated automatically for any bound GC or HPLC data file. Summary: signal-to-noise in chromatography. Signal-to-noise ratio in chromatography is calculated by comparing peak height to RMS baseline noise, both derived directly from the chromatogram trace. Chromperfect implements this calculation in a transparent and reproducible way using chromatogram functions and formatted reports, making it suitable for GC, HPLC, and routine analytical workflows. Supporting documentation is linked below. Thank you for watching. Please like this video, subscribe to our channel, and hit the bell icon to be notified when we upload new chromatography training materials.